Hi guys, welcome back. It's good to have everybody here and kind of get started and get the ball rolling. As you remember back from break, quite a few weeks ago, we were starting to talk about probability. Right now we're going to be talking about probability and talking about percents, taking data and being able to understand the frequency of how events occur, how numbers occur, and kind of the relationship between them all. So we're going to do a little bit of review. You guys all have notes and packets that you'll need to be completing. And if you guys kind of watch the intro video, kind of explain what the expectations are for the classroom, as well as there's a document and a little quiz for you to say that you kind of understand and accept the responsibility for what is expected for the course. Again, if there's any questions, just let me know, but we're going to go ahead and get started. Make sure you have your probability notes out. They should look something like this. This is something that's going to allow you to be able to kind of follow along and take notes for today, as this is our introduction and kind of getting us started. This is also going to allow you to do some work and be able to upload your work to me so that I can see it and grade it. That is kind of how we're doing our work here on out for the rest of the trimester. So if you have questions, again, let me know. All right, so let's go ahead and get started. So probability. Well, what is probability? Again, probability is the numerical description of how likely an event is to occur or how likely that proposition is true. So probability is represented by fractions, decimals, and percentages. So what you see down here in these examples is this is percentage, how many apples were eaten. And as we can see here, 20% out of 100 were eaten. 80% of apples were not eaten. So being able to look at those percentages. If we look at here, we see decimals and pie charts. We're able to see that 0.25 of this pie chart. We're able to see 0.5 or half, 0.75 or one whole. This is a way for us to kind of look at decimals and representation, and they all kind of relate. And then our fractions, our pie charts, we're very common and we see these all the time. I mean, think of a pizza, especially if you get something from Domino's. You often have 8 pieces in a medium pizza, exactly like this one right here. And you're given a percentage, you're given, a certain amount, you're given a fraction of what you're going to be eating. So it's being able to understand the probability of something to occur. So understanding probability is very important, and it's actually something we use in everyday life. So let's take a look at the probability of a spinner. Given the following spinner, we need to determine the probability, right? What is the probability for orange? What is the probability for red or green? What is the probability of it not landing on pink? What is the probability of it landing on pink? Well, we can go ahead and look at this and say there is no pink. So the answer for this one right here is 0. There's a 0% chance that the spinner is going to land on a pink because there is not a possibility. There's no pink involved. For this one right here, not landing on red. Well, if we look at that, we have a total of 4 sections, 1, 2, 3, and 4. We know that a whole number is 1, all right? And we know that a quarter, all right, or a fourth right here is 1/4 of a whole. So the probability of it not landing on red is we have to minus a fourth from this. So then we're left with 3 parts. So you can do this many ways to figure out probability. Obviously, with the advanced brain that I have, because I've been studying probability for 26 years, I know that the probability of it not landing on red is 75%. Because 25 plus 25 plus 25 is equal to 3/4 and also equal to 75% of it not landing on red. Now, if we were looking at the probability of red or green, well, red and green right here, right? And that's about half of the spinner. So half, right? 50% or 0.5. That's the probability of it landing on red or green. And how about the probability of orange? Kind of like when we were doing things backwards with red representing 25%, orange represents 25%, right? And to be honest, every color represents 25% or 0.25. and a decimal, right? Um, so these are things, or 1/4 actually, that's as in a fraction, because there's 4 parts, and this is one of 4 parts. So these are, 3 different ways you can look at a spinner and figure out the probability with this given information and asked to find. So probability of a spinner, this is a very simple example of how you can find that. So probability of dice, well, I'm not going to go into depth in this, only because what you see here is that you have a dice chart, right? And you're given, the rolls, and then you're given what, the probability of getting what on what roll. Essentially, the reason why I put this up here is that there's probability when you're rolling dice every single time. That's not the only thing there's probability in. There's probability in the deck of cards. You're given 52 cards, not including the jokers. You're given 4 suits. You have spades, hearts, diamonds, and clubs. Of each suit, there's 13 cards of each suit, all right? So it's broken down even further than that. There's 4 of each card, an ace through 10, all right? Then it's broken down even more into 4 jacks, 4 queens, and 4 kings. We know there's 26 red cards and 26 black cards. Now, if you were asked to figure out what is the likelihood of you drawing a black card, you could say 50%. Because there's exactly half of black and half of red, right? But if you were to ask, what is the likelihood of you drawing a jack of spades, that's a very hard thing to figure out with probability. But there are ways you can figure that out. And we're going to get to that, probably not that complex in this class, but just kind of giving you an idea that probability is pretty much everywhere. Again, probability is everywhere. There's probability in gambling. What is the likelihood of you to win? Obviously not very likely. Casinos are there to make money, and if you win, that's awesome, but the probability is low, especially when you're playing games. So oftentimes people want to play things that you have higher odds of winning, but it doesn't mean you're going to win more money. That's why people generally like to play games where you have a lower chance of winning a higher amount of money because you get more of your profit. But again, it doesn't always work that way, but it's also a chance kind of game. Probability is also seen in baseball. We see that in baseball only because, what's the probability of this hitter? What is the likelihood? What is their percentage of hits? Even we see this in football and tackles, or the amount of touchdowns. We see this in rugby. We see this in bowling. We see in soccer. We see in every kind of sport. We also see it in voting. What is the probability that somebody's going to win? And we also see it in science. What is the probability you're going to be tall, and what's the probability you're going to be short? Are you going to have blue eyes, black eyes, brown eyes? Are you going to have blonde hair, red hair, brown hair, whatever? There's a lot of variations. Probability is very important, and it is something we learn about every single day and utilize in our lives every single day. So that's kind of what we're going to be talking about and learning about over the next few weeks, because we need to understand probability because we use it every day. Believe it or not, and even when you don't even think you're using it. So one thing to remember is probability measures how likely something is to occur, right? We use decimals, percents, and fractions as a means of measurement to help us understand probability, and probably uses the numbers 0 through 1. Numbers towards 0 are less likely to occur, and numbers towards 1 are more likely to occur. You can think of this as a percentage, like 0 to 100, so like 100% is an A and 0 is an F. Those are kind of ways to think about it. You can think of a lot of different ways, but you will always use the numbers 0 through 1. You should never necessarily go over that, and we'll kind of get into some of those fractions and percents and decimals a little bit more as we move into more probability and percents and those things as well. So just remember 0 through 1, 0 less likely, 1 more likely. All right, so we're not going to play a game about probabilities. We're going to skip over that. Again, probability is everywhere, so just remember. So ways to display. Well, this is in your notes, a histogram. It's a frequency display that uses bars to show distribution of data in a set. Each bar represents an interval, a range, or of data. So keeping that in mind, histograms are different than maybe a bar graph. So if you need a second to pause this video to write down these notes, go ahead and do that. But otherwise, I'm going to keep moving on. So what is the difference between a bar graph and a histogram? Well, a bar graph has gaps in between the bars itself, and it talks about categories. It separates things into categories, like the U.S., how much money they made, you know, selling oil, let's just say that, and it compares it to other countries. It's talking about categories. Histograms, there's no gaps in between the bars, and it's talking about number ranges. Remember, ranges of numbers. So if we go back to the definition of this, it's a distribution of data set. Each bar represents an interval or a range of data. Interval or range of data. We're not talking about categories, kind of like what the bar graph is saying here. So we're going to start putting this to practice. So in your notes, you guys have copies of all of this information in your note packet that you're going to be asked to do. I'll quickly go through it all, but then you're going to be asked to do this and upload it for class points today. So let's put it to practice. Over 11 days, you track the data of temperature highs for the month of February. You lower your temperatures that you have gathered. So now we need to figure out, how do we put this to a graph? All right, so let's take a look. All right, so you're first going to set up your graph, something like this. Remember, we're not making a bar graph, we're making a histogram. So you're going to set it up, and you're going to want to figure out where your days and temperatures go. I would highly suggest that you probably put your information of temperatures over here, because you're going to be looking at a variation of a range of temperatures, okay? And then you're maybe going to want to look from, days as well here. Otherwise, another way to look at it is to make sure that when you're putting your days here, is letting us know how many days do we have this range of information. What was the range of us being in temperatures, 20 to 30, for that given year. We look at this yearly to kind of determine the times of year to travel in other states and other countries too. This is kind of how I set mine up. Again, you have your days here, and then you have your frequency of temps, and then between what you're going to do is going to be drawing your bars. When it's all said and done, you should have something that looks something similar to this. Whichever way you decide to put your information, but it should not be categories, okay? Making sure your days are going vertical, up and down, and that your ranges are going horizontal, side to side, left to right, okay? This is going to help you understand and be able to see your data a lot more clearly. So as you do your worksheet, make sure you have something that looks similar to this. All right, the next thing you're going to be doing is you're trying to see how many customers you have at certain times of the day to see how many employees you need to schedule for work. So let's put the information to a histogram. So this is a lot of information kind of thrown at you on a table. The reason why we're creating histograms is so we can figure out exactly what we need to know. The best way to do this is to go ahead and you're going to want to figure out your averages, or figure out the total amount of people you have at a time of day. Okay, so essentially 10 to 11, 11 to 12, 12 to 1, 1 to 2, 2 to 3, 3 to 4, and 4 to 5. Okay, and you're going to want to have that. How you want to set up your histogram, this gets a little complicated. So how I set mine up is something similar to this. Now ignore these numbers here because these aren't really going to matter. What's going to matter is how many customers you have. So when you're looking at, remember, a histogram is understanding a range of data, a range of information. So what you're going to want to do is you're going to want to put your time frames, okay, over here. Your time frames are going to go vertical, all right? So you're going to go 10 to 11, 12, and so on. And then here is where you're going to put your information of how many customers you had in all. Sorry, scratch that. Vice versa. I totally said that wrong. You're going to want to put 11 to, or 10 to 11, your times down here, I'm sorry. And then you're going to want to put your range of number of people here. So you can display that information and look over, hey, from 11 to 12, I had such and such people. In comparison, from 2 to 3, I had such and such people. So I need to employ this many people at this time, and only need to employ this many people at this time. So again, just to reiterate, I made a mistake. Teachers make mistakes too. Make sure you put your times down horizontal left to right, and the number of people vertical up and down. All right, so the very last thing you're going to do is you're going to go ahead and scratch off the dice game histogram. Don't worry about that, just cross it off. Obviously, we're not together to play the game. If you want to go ahead and do this on your own for extra practice, and if you have some dice, you can go ahead and play with a sibling or do this for yourself. Feel free to do so. Otherwise, you do not have to do this. The last bits of information we're going to go over is numerical data and dot plots. We'll talk a little bit about this a little bit tomorrow, but I just want to make sure you get this information down so you have a little bit of knowledge going into tomorrow's lesson. Numerical data involves numbers and quantities. Okay, numbers and quantities. It has to deal with, the amount of something. Okay, box or plots or dot plots display the frequency of numerical data. So this is actually supposed to say dot plots. So make sure you cross out box and write dots. And it uses dots to show how often a number occurs. So right here you can see that we have a various dots, and it talks about minutes to eat breakfast, and it's telling us what is the frequency of people eating at don't eat breakfast at all, who eats at 10 minutes, who eats at 6 minutes. That's kind of what a dot plot shows, is the frequency of data. Mean, median, mode, and range. This is going to be used a lot during our lessons. I'm not going to go too much in depth today because we're going to go through it tomorrow. Just make sure you jot this down in your notes. What you have on your paper is a little bit different than what I have, but just make sure that you take this note somewhere because you're going to need to know what these mean. This will also be on your quiz because you will have to do some matching of some sort so you understand this. This is going to guide you through a lot of the information and a lot of the stuff we're going to be doing over the next several weeks. So if you have questions on this, please make sure to ask. Otherwise, do your best to memorize this. This is going to be key information for you. Mean, median, and mode. Okay. And again, I'll go over this a little bit later. All right. Quartiles. Quartiles are the values of points in a separation of the data set for 4 equal parts. Okay. Quartiles, again, we'll go over this a little bit later, but just so you have this down quickly. The first quartile separates the lower half of the data information, and the third quartile separates the upper half of the data information. They both separate them into 2 equal parts. So understand that there's a separation. Some people have asked, is there a second quartile? No, because that is actually the middle of information. When we look back at mean, median, and mode, that's when these phrases and terms and numbers will be coming into play. So you only have to remember quartiles, what it is, first and third, and what it is too. So the next thing you're going to do at the very end is you're going to be creating a dot plot using this information. You have the number of pacers the students have completed, and now you're going to create a box plot. If you need help, use the reference from the slide to make a dot plot, and so that you can create your own on this. Again, your work is due by the end of the day today, so make sure you get that uploaded. If you have any questions or anything about your notes, just let me know. Go ahead and answer this, and then we will help get you set up. Other than that, have a great day. Thanks.